Hello and welcome to the week 3 poll activity video. It's going to be a long one, so let's just jump into it because if I have to start back over, it's not going to be fun if I had a big preamble. For the record, just skip around to where you need to go. I'm going to go through the first example, although this might actually be more of like the summary example and something you should come back towards nearer to the end once you've kind of gone through some of these more simple examples. But let's dig into it from start to finish. So I'll be holding this over to the side and mostly just using that to record answers. I'm going to be focused over here in the code, and let's make it slightly larger. There we go. Lovely. Clearing that. Okay, so looking at this code, we just have to start breaking it down. You have to identify your order of operations, and that's just going to be true in general. It's also just an important skill to learn. And really, as you're going through these, recognize that part of the reason we're doing this is to get you thinking about the cause and effect of code, thinking about it as a process, not something that occurs at once, because it doesn't occur all at once. There are steps to it, even if you can't see them. So for example, in this code, there are kind of 4 main sections. How to count that in the moment. We have this part I've just highlighted. This is the first extraction that occurs, and it's going to open up the second column of iris. And just one thing to know is whenever we are using these 2-dimensional extraction tools, and when we narrow it down to a single column, and just in general, when we get down to a single column, typically in a data frame, it will be simplified to a vector. There's plenty of, not truths about that, but for the most part, in R, when you get down to one column, it's going to become a vector. So there we are. There it is as a vector. If I had not used a comma, so I had tried to do a one-dimensional, that is one of those exceptions where it would actually stay as a data frame. And that's going to cause some problems later on for a number of reasons. But what's going on here is I'm trying to isolate a part of iris using a one-dimensional tool, and that's not right. Iris is this 2-dimensional data frame. There is a one-dimensional view, and that's as its list structure. So this is that first container in that list underlying structure, which is a vector of containers, essentially. And so not what we wanted. That's what we wanted. That comma is indicating our 2 arguments. This right here on this left here on the comma is indicating the rows we want to select. And since it's blank, we're just saying we're not subsetting. We're not like lowering the number of rows. We're just taking them all. But on the right side of the comma, where we indicate our second dimension, which in R is defined as the column dimension of a data frame, we are this time subsetting. We are reducing from what used to be 5 columns to 2. Okay, I'm not going to repeat that whole breakdown every time, but there it is. Next step. We would want to do this entire extraction here of the data we just extracted. So at that moment in time, we would have a vector of values, and we would be extracting from that vector. And if you parse this, you'd learn that this is a one-dimensional extraction. That makes sense. However, there's a problem. This can't happen because it doesn't know how to do it yet. So this is where I talk about, like, you can usually suss out the cause and effect. And in this situation, I can't resolve this wide square bracket tool until I've filled out the insides. Well, I can't do this comparison until I know what I'm comparing it against. And so really the next step is to determine what this currently highlighted code is going to do. In this case, it's similar to the first one. It's a 2-dimensional extraction using an integer by extracting from iris. So that's what it looks like. Looks very similar to the last one, but it's different numbers because it's a different column. At that point in time, now that comparison can happen. And this is really just, you need to start being able to break it down, and you also need to start predicting. And that's just really how you start to get good at this, is you predict what's going to happen, you check to see if you're right, and when you're not right, you rectify your understanding, and you grow from that. And this is really what we're trying to encourage with these activities. So I hope, looking at this code, if I tell you a bunch of numbers, which is what all of this stands for right here, compared to a single number, what you're going to think the response is trues and falses. And if you didn't think that, well, think about it harder. How else am I going to resolve 1.4 greater than 6? 1.3 greater than 6, 1.5 greater than 6. And so it's just going to, those are false statements, and that's how R interprets it. Whenever it does these comparisons, it is going to return trues and falses. But that's why it makes sense that it returns trues and falses. Okay, at this point now, we have the data that this all resolves to. It's a series, so a vector, of true and false values, so a logical vector. That is a single object once this has all been resolved together. That is then being passed to the first and only argument inside of this wide square bracket. The other argument to that wide square bracket is what is ever to the left of it because, well, square bracket just has kind of a weird syntax. So we're going to take that object to the left and we're going to extract it using the stuff inside of the square brackets. So in this case, we're taking these values and we're extracting based on this logic. So that's a one-dimensional extraction. So in summary, a vector-like extraction was used. I've currently highlighted, at least, there you go. Now I've highlighted the vector-like extraction. Technically, it actually includes all of this, but most of the time, y'all just want to kind of be pointed towards the tool. A two-dimensional extraction that subsets the row. Actually, none of these subsetted the row. So that subset's based on column. So it's reducing the set in the column, reducing the set in the column, but neither one is based on row. And then that wide one, well, it's not based on row anymore. You're right that it corresponds to values in the row, like from the original. However, like the mechanics of the extraction are doing this now on a vector. So it's not the original data anymore. It's just based on the rows. So I get the argument. I'm more trying to be a little bit more pedantic in this regard, mostly because it makes a better exercise to be so. The things that are controlling this is an integer vector here, an integer vector here. So even though those are just single values, those are in fact length one numeric vectors actually. So if I just type, and if I wasn't ever sure, I could literally just type in, well, what is the class of just 2? And it turns out that just a raw number like that gets typed as numeric. Just what they do. It wasn't my choice. A logical vector is used, so that's occurring right here. A logical vector, and it's being used inside of an extraction. And then there was no character vectors used in this, so we'll see some examples of that later on. No dollar signs used in this, and then the output is, think about it, a vector. We know it's a vector. The thing we're extracting from at the end, so once this is resolved, this resolved to a vector, and then we're extracting again from that, so it's still going to be a vector. A data frame, you can usually remember the difference. It's very simple. If you end up with multiple columns, it's almost always going to stay a data frame. If you end up with a single column, it's almost always going to be simplified to a vector. It's not always true. It's hard to say ultimatums here, but like the general pattern is that R simplifies a single column, but not like one row. So if I do iris 1, comma, all columns, so one row, all columns, that's actually still a data frame. Contrast that with this, which is no longer a data frame, even though these codes are very similar. That's an asymmetry you just kind of have to memorize about R, and it's just one of the quirks of these tools. Okay, next up. Next up, we are looking at how this data is changing shape as we access iris. Iris here being extracted with a single extraction tool. I've highlighted it right there. That extraction tool has two arguments. It has this single value, and yes, that is ultimately a single object or a single data set. That data set has two values inside of it, so it is a length 2 integer vector, it turns out. I don't care if you knew if it's an integer or not, just care that you know it's numbers. That means it's going to be based on position within the data. Those are going to be applied to the row dimension because that's the order of the square bracket tool when applied to two-dimensional objects. So this would be row, and then this is saying all columns. So just blank means all. So this is a two-dimensional. We are subsetting the row. We are not manipulating the column data frame or column dimension. It is an integer vector being used, and the output is a data frame. And if you didn't listen to that first question, the reason why is that a data frame is going to result anytime I have multiple columns in my output, or at least most of the time when I have multiple columns, outside of other factors coming in than just these tools. Next up, we've got this fairly simple one. It's pretty much the same thing as last time. We are doing a two-dimensional extraction. We are restricting the number of rows, but this time we are also restricting the number of columns. So this is going to be basically the same, except this time we are both reducing it from 150 rows to 2 rows, and then also from 5 columns to 1. Now the other big change here, besides still integer, is the output. Since we are narrowing this down to a single column, the output will be a vector. And if you have the question of, well, how do I know it's an atomic vector? Well, atomic just means you can't divide it further. So like an atom can't be divided further, or at least when the word atom was coined, that was being the thought at the time, that it was the simplest unit of matter. And maybe, well, let's not get into particle physics. That would be a very different thing. But so here we are referring to these numeric values. Well, there isn't like, what is more simple of numeric type than this, right? It's just a series of values. The only thing that would potentially be simpler is if there was like a type of data that was literally just like, you can't have a vector, you can only have a one value. So like a 0-dimensional object. There is no dimension, it's just value. R doesn't have that, or at least the vast majority of types don't have that. I don't know of any object that has 0 dimensions in R. Most of our, well, all of our simple atomic types are vectors. So they allow for one dimension of values to exist within them. So that's it. That's why it's indivisible. That's why it's atomic. So those are going to be the most simple ones we talked about: logical, numeric, integer, or numeric / double, character. We talked about factors a little bit. These are all our very simple types. And factor is that, I don't actually know if factor is considered the simplest because it's kind of an integer. Anyways, the point being is that our atomic vectors are our very simple vectors, not a list, in other words. Okay, code. Select 4 boxes from this one. Well, right off the bat, we have a extraction here that is $sepal length. Please note that there's no quotation marks around that. Do I really consider that to be a character vector? I don't really. If I do this, which does actually work, I would then consider that a character vector. This, though, probably under the hood is processed as a character vector, but at least as written, we're not creating a character vector. Because if I try to just do this, that's nothing. That's not a character vector. It's not an object. It's something else. And it's just because that's what the $ tool does, is it allows us to refer to columns based on their name, but unquoted. And there's some special properties there that's nice about, but that's just how it works. The second extraction occurs subsequently. And again, this is where the order of operations has to be considered. What are you pulling positions 1 and 2 out of if that $ hasn't happened? Well, you'd be pulling it out of sepal length, but that's not a thing. Like, sepal length isn't an object that exists. It's a column inside of iris, or a container inside the iris type underlying list structure. Like, however you want to say it, sepal.length by itself is not an object to extract from. And so it can only happen once this has occurred and this data is no longer inside of a list object. It's now the input to the left side of the square bracket tool. So when we run this, we're going to get the first and second position. So we should see those 2 numbers come out. And that's in fact what we see. Something to point out is that there is no comma in here. And the reason why is that after this first extraction is run, it's no longer a data frame. So it is appropriate to use a one-dimensional tool. So a vector like 1D extraction is used, absolutely. A 2D extraction, there are no 2D extractions here, so I'm not going to select either of those boxes. An integer vector was used right there to subset the dimension based on position. A logical vector, nope. A character vector, maybe. But there's a better choice here of a $sign, so we're gonna do that one. And then finally, what type of output will we have? In this case, the final output is some number, so that is an atomic vector. Again, if we'd somehow, that'd be hard with this code, if we'd somehow ended up with multiple columns, that's when you would expect to see a data frame. We didn't, it's a vector. This next line of code is, again, doing the exact same thing. We're going to get the first and second row, but at the same time, in a single two-dimensional extraction, we're getting that column. This time we are using a character vector, and so it goes like thus. A two-dimensional row subsetting, a two-dimensional column, but these are the same extraction, so this is happening all at once. A numeric vector was used, and a character vector was used. So just for the record, that is a one-length character vector. That is a two-length integer vector. And actually, this was our... Yeah, there's been a couple. So this is just, yeah, we're good. It's a long video, so I'm just going to move past that little blurb. Welcome to the sausage being made. Okay, moving forward. Next up, we got... was that a typo? Or is that just... No, that's just my screen glitching. Weird. Okay. Okay. I don't know what that's about. I don't know if that's coming through on your end. I'm just seeing a bit of a graphical glitch. Interesting. Okay, so here we have our code. We are looking at rows 1 through 2. We are looking at the combined values of species, comma, sepal length. Although on my screen it's spelled simple length. Anyways, I don't think that's correct on what you're seeing. So here we have, again, an order of operations. This wide square bracket can't occur until the inside arguments are resolved. So this side is easy. It's just 1 and 2. But that's originally a length 1 numeric vector, a length 1 numeric vector. Together, after the colon operator has occurred, done its function thing, it is a length 2 integer vector. And that's the input to the row argument. So that order of operations really matters. Again, here we have a length 1 character vector. A length 1 character vector. But once the C function has occurred, we have a length 2 character vector. So a single set of data being sent to the other argument. That's appropriate because each of these arguments required a single set of data to be passed to them. That's why we had to combine those two arguments. Had I not combined them, so I'd done something like this. I'm going to look at my other screen. This is now a 3-dimensional extraction, and something weird's going to happen. So we're getting some stuff that's kind of hard to interpret, and it's probably mostly related to the fact that, well, there's no third dimension with a position named sepal.length. And the reason why it worked previously is that wasn't two separate arguments. That's a single argument with two values. It's actually the exact same thing as what's going on over here. It just looks more wide and complicated because it's character values which require us to use the C function to combine specific values. So that's what's going on. So this became the column dimension constraint. This became the row dimension constraint. And let's just answer those questions now. I'm subsetting the rows. I'm subsetting the columns in two-dimensional extractions. One was an integer vector, not a logic character vector. Now this time, because we're returning 2 columns, whenever you're returning 2 columns or more, you should expect a data frame, at least the majority of the time, unless there's some other function, up in the mix. But that's not what's going on here. It's just going to be outputting multiple columns. So it's going to retain that data frame structure to ensure that those 2 different types of data, which they are in fact 2 different types of data. This is factor data here, and this is numeric data here. Those two different types of data have different properties. They're stored in memory in different ways. You couldn't combine them into a single object. And if you did, you would actually end up causing, so if I use the unlist function to pull them out of that data frame, you end up changing things. And this is where we can see the kind of funkiness that is a factor, because it's actually stored in memory as an integer and then just given some extra properties. Very strange. So we see numbers. This is why I don't like factors. It's very confusing at times, especially when you end up with numbers stored as factors. And so like under the hood, they're stored as like the value 3, but they look like the value 1. It's very confusing to people. Okay. Next up, we've got another one, but this one getting a little bit fancy with it. I'm just going to make this full screen for a brief moment. At its core, this is extracting some data. Here we have two columns being selected. And then on this left side, we have some rows being selected. And so the outcome is slightly shorter. So it's 141 through 150 and across two columns. Well, the column dimension is pretty easy. It's the exact same scenario as the last question. I'm not going to go into that. We just went through it. So go check that question out if you were confused there. But this left side, much trickier. So this is really where we have to pay attention to order of operations. Let me make that a little bit bigger just to help explain. So we can see that if we really just parse it, and right now I'm hovering my cursor near the parentheses, I can kind of see it glowing where its matching parenthesis is. So in between there, that's going to have to happen first, because if nothing else, it's going to follow the rules of math in terms of order of operations. And so parentheses, for sure, going to go first. That means this stuff in here is going to go first, but this is actually two functions already. So the in row of iris, that's number of rows of iris, that's 150. Well, that hopefully means that you recognize that together, that becomes 1 through 150. 1, 2, 3, 4, all the way up to 150. That's the end of this parenthetical. Now there's a comparison, but on the other side of the comparison, there's this math. Okay, so we have to resolve this math first. So here we have the number of rows of iris, 150. And then we have minus 9, so 141. So now we have all of these values that you're seeing here greater than or equal to 141. Right, so that is going to be a logical statement, because if you just think about it, all right, that's like literally saying 1 greater than or equal to 141. 2 greater than or equal to 141. And for the record, why students tend to make a mistake here and think like, yeah, that's going to be 141 and 142, instead of the logic that it actually is that they're trying to think with like intent, as if the code has any sort of intent beyond what you say. It doesn't. It only knows what you say. And that's really part of the goal of this whole unit, is to get you thinking like a computer. From the computer's perspective, this is just a series of steps. It doesn't know what you're trying to do. It doesn't know that you want rows 141 and 142. It only knows what you tell it. And what you've told it is create a logical vector by comparing each of these values to the number 141. That's what it knows. Now, it ends up getting used that way because we're very creative and we're clever and we've studied these tools a little bit at least, and we're starting to put it together, and because we know that logic can be used in an extraction. So here's an example of a logical vector being used in an extraction for the row dimension. I'm going to move over to this other side quite quickly. I broke this down in the previous question, but basically we're just taking species and sepal length, which are length 1 character vectors by themselves, but they're separate. So we need to somehow stick them together so that we have a single argument that becomes the columns constraint. Well, that's what the C function does. It combines things. C stands for combine. So we are combining it into a length 2 character vector that looks like that. And those are our two inputs, some logic on the left and a length 2 character vector on the right. Let me just reset here. Lovely. Okay, so we have no one-dimensional Correct. No one-dimensional extractions here. A two-dimensional extraction, subsetting row, two-dimensional extraction, subsetting column. We are using logic and we are using characters. There was no numeric numeric-based extractions here. Finally, the output of this has two columns in it, and therefore, based on this, and therefore it will be a data frame, not a vector. So 1, 2, 3, 4, 5, done. Next up, we have another similar chunk of code where we are generating a vector of values. So the first one is going to be a long series of values. Please go to the previous question if you just jumped here. And then we're comparing those values to the number 3. So I hope now you're realizing that that's going to resolve to a logical object. So a comparison, 1 compared to 3. Well, what's less than? So I've used the less than symbol. So the answer is not, 1. The answer is true, that it is, in fact, less than 3. And if I do that, and I scroll all the way up, I see true, true, and then a bunch of falses. On this other side, we have a very similar situation, although the number of columns of iris is 5, and so this becomes 1 greater than 3. Well, that's not true, so that will be false. 2 greater than 3, that's not true, that's false. 3 greater than 3, still false. 4 greater than 3, true, and then true. So at this point, we have both arguments to our single extraction here. So we're using rows and columns to be subset. We are going to end up pulling out multiple columns, but this is all based on logic. There are no extractions using numeric values. One thing to note is students will be like, yeah, but doesn't that represent information about the index number? And you're not wrong. Like, conceptually, I know that what went into this code was thinking about those integer vectors. But from ours perspective, literally all it sees when it does that square bracket tool is this logic. So it doesn't care about your intent. It only cares about what you gave it in terms of data. And the output will be data frame because the output has two or more columns. And that's what it looks like. Okay. Next up, we have one. Most students are getting this at this point. So if you're just jumping here, I know what the common problem is, so we'll get there in a second. But this left side is using the square bracket tool. So for the record, this is equivalent to what you have seen us do previously with $sign. The difference is that this is a character vector, whereas this is kind of a unique syntax to itself. And the other thing, of course, is that it's got these two square brackets. But this is just the double square bracket tool. It works on list type data. It allows you to open up a single container at a time, just like $sign. It is equivalent to $sign. It's just got slightly different inputs. On the right side, so once that double square bracket has occurred, we have a vector. It's called a factor vector. And then we are extracting the first and 100th position. So there we say setosa, and there we see versicolor. So in this case, we have a single extraction. You could probably say it's a one-dimensional extraction. Maybe not. It's definitely not a two-dimensional extraction. So let's just say it is a one-dimensional extraction. We'll say that's definitely a character vector being controlled in there. The $sign's not being used, but we are using the positions here. So there's a numeric-based vector. And finally, the output is going to be a single vector, and so the output will be a single vector. The single vector is because what we're extracting from is one-dimensional, and then we're extracting, well, one dimension from that, which makes sense because it should agree. And so your output is still one-dimensional. It's a vector. I think actually a worthy question is factor an atomic vector? And well, let me go research that real quick and just make sure I'm not going to tell you wrong. All right, cool. So I was right. So a atomic vector is one that can't be divided further. it turns out a factor is stored in memory as an integer, and then it has a little bit of extra properties to it. So in essence, you could divide it further. You could kind of pull out the values that what those values stand for, so what we call the levels, and you could pull out the integers that underlay them. So in theory, I should actually change that output. That the output is a factor vector instead of an atomic vector. So that's technically untrue. So I'll have to go fix that. But it is a vector for sure. It's definitely the best choice there. But yeah, it's not an atomic vector because of that. That was a question earlier in the thing. That's why I'm phrasing it this way. So sorry about that. I'll have to fix that later. Okay, next up we've got a more complicated code. This is our most complicated in this section. Really more just for fun. I think it's fun. So here on the left side of our comma, so on the side I've currently highlighted, which is right here, we can see that this code altogether has a parenthetical around it. This is going to all be occurring before those values are compared to the number 1, and that will then complete this entire left side of the comma. However, to determine what this is all going to resolve to, we have to take it step by step. And so you have to kind of work your way in. And so we can see that, all right, this connects to this. So that must happen before the equals. Well, then we have this %%, but again, there's a parenthetical on this left side of the %%. And so even if we're not sure, like the parentheticals have forced this to happen. So this must have happened before the %%. And even before the colon could happen, the in row must have occurred. And so that is kind of our very first thing that has to end up happening. That's generally how you want to work. You work from like inside out and kind of left to right. And it's a bit tricky, but it's really just cause and effect. I can't do each of these next steps until the previous step has finished. So here in row, it's 150. That means 1 colon in row becomes 1, 2, 3, 4, 5, all the way up to 150. And then we're applying this mod function. So that's just what we call this. I gave you the definition of that. It returns the remainder after dividing the left side by the right side. So for example, if I take the value 21, if I divide 21 by 20, well, that's divisible 1 time, so 1, and then there's a remainder, 1. The remainder is 1. If I am doing 22 divided by 20, it divides once, but then there's a remainder of 2. If I do 40, that divides twice with a remainder of 0. If I do 41, that divides twice, but with a remainder of 1. And I hope you're starting to see the pattern. So it's just remainder. It's just what you learned in grade school. You just probably haven't used that term in a long time. If we visualize what that looks like, we can see this pattern here where it goes across, and then there it is starting to repeat. So there's the next one, third one, fourth one, fifth one, sixth one, and they're just occurring at different positions in the data. So for example, this is occurring at 145. Well, 145 has a remainder of 5 when divided by 20. Okay, so if I then take those remainders and I check to see where they're 1, I essentially am getting a true every 20 values, starting at position 1, because that had a remainder of 1, and then at position 21, and then at position 41, and then at position 61, and so on. That's it. So that ends up being a logical vector that's being used for this 2-dimensional row dimension. This right side, a little bit trickier. And just in case that graphical glitch is affecting you, let's scroll to the left. This right side is a numeric vector, or an integer vector actually. This integer vector has negative values. And again, I give you a little tip here. Negative index positions remove those positions from the return value. So instead of returning column 1, it will remove column 1. So kind of extraction by subtraction. Wish I hadn't said that phrase, but Kind of true. Okay, so altogether, we're going to end up with columns 4 and 5, and we're going to end up with the rows that were true, so about every 20 rows. And that's indeed what happens. Kind of fun, right? Handy trick for just scanning through some data set real quickly and finding like an interval, just nice and simple. I use that trick actually fairly often. So in this case, a two-dimensional extraction does extract from the column dimension, and it is using a numeric vector, or integer vector specifically. The output's a data frame because, well, we've restricted it to just 2 columns. Okay, that's the end of that first section. Okay, so looking at this next line of code, I'm probably just going to go focus on something like one thing at a time. So let's just open up R and make that a little bit bigger. So in this situation, honestly, I had these like little phrases in here. I don't know if it was helpful. Let me just more focus you on the code and maybe we can talk through it. Now, when I look at this code, I can just read it. That's a skill. It really takes some time to build. So like I look at this code and I know that I'm going to extract the rows of iris across all columns because of that length there, where the sepal length is both less than 5, and I know it's both because of that ampersand, less than 5, and the sepal width is less than or equal to 2.5. And so like I just read it like that. But it comes with some practice. And so like this is really trying to just get you to start thinking in that way. It's going to take some time. So to break that down, it is a subset of the rows. And so I know it's the subset of the rows because, well, this is going to be constraining the rows. The columns aren't being subset. It's all the columns. So across all columns of iris, where the sepal length is less than 5 and the sepal width is less than or equal to 2.5 is what I was going for. Biologically, I could actually rephrase that, and I could say it is the, we are going to extract the rows describing flowers of the iris data set that have sepal lengths of less than 5 millimeters and sepal widths of less than less than or equal to 2.5 millimeters. And you know, if I didn't know what the units were, I could look up iris. And we could see if those were in fact millimeters or if I was guessing wrong. Oh, did they not tell us here? Well, that's just rude. They should tell us. I guess I'd have to go do some more research. So let's just pretend I'm right. And if I'm wrong, don't tell me. I'll learn eventually. From the Annals of Eugenics. Wow, I did not realize that that's where that's from. Maybe we should move over to penguins. Anyways. Let's do this next question. That got dark. The values from iris, the petal width values in iris, where the sepal length is less than 5 and the sepal width is less than 2.5. There are a few other things that we're seeing here, that there is no comma inside of this. That's because what it's extracting from is a vector of just the petal width values. Note that's the difference here. This was just petal width, while this was all of iris's columns. So again, the way I'd read that, it's the values of the petal width, and then with those constraints. Again, biologically, if I was speaking to a biologist, I'd say I'm extracting the petal widths for flowers that have sepal lengths less than 5 and sepal widths less than or equal to 2.5. Just focusing more on like, no one cares about the rows and columns. When you're talking to the scientists, they want to know about the science. Okay, next up, we got QLogic being created. That actually doesn't change anything. It's the exact same thing. We are, again, extracting the petal width values where this stuff is true. So I could say it the exact same way. If I really wanted to, I could also say an intermediate object named QLogic was created based on that information and used in the row segment of an extraction tool. But again, no biologist cares. Like, that's just the mechanics which is, maybe the kind of the ironic part of learning the skill set is it's the background. Like the mechanics don't matter. What matters is how you can do these analyses. But it turns out you still have to be able to figure out these mechanics in order to do these analyses. I think it's fun. And don't get me wrong, like I do not feel unappreciated. My colleagues are always so thankful that I have these skills and I can help them on these steps that they struggle with. It's a legitimate skill. Next up, we have this same code, but this time we have replaced that ampersand with a pipe symbol. That's going to be a logical OR as opposed to a logical AND. And so what we're doing is we are taking this left side and we are combining the logic it produces, so a bunch of trues and falses, with this right side. But this time, instead of where they're both true, and extracting those rows, we're going to say where one of those is true. So the way I would end up phrasing that is I would say we are extracting the pedal width values where either the sepal length is less than 5 or the sepal width is less than or equal to 2.5. And that's really how I kind of want you thinking through these things and practicing speaking these out. That's why I think this exercise really benefits from you talking to people. So if you're going back through this, try to practice reading that out and just checking your own work, listening to yourself. Hell, you could record yourself if you want to. I'm giving you lots of demonstration here. All right. Next up, it says describe in words what which does in the following. So let's run some of this demo code so that we can see what which is going to do. So here I am testing if column 2 is less than 10, and I do see that there's some missing information in column 2, but then I see trues and falses otherwise. If I run the which on that, though, I get 1, 2, and 4, which corresponds to 1, 2, and position 4. So the difference here in what which is doing is which returns the positions that are true. Not literally the values true, it returns what index those true values occurred at. And this is useful because it turns out if you are including any missing values in an extraction that utilizes logic, well, you get missing information out. You can't do an extraction using missing information, so it returns missing data. That looks weird because we actually had more information in the original data set that look like they've been removed, but it's just that you didn't extract the third row. You just added an entire row of nothing, of missing information. That's a problem. Most of the time that causes a problem. And so a very simple workaround is that when you are using logic in an extraction, instead of doing those true and false values, you can wrap a which function around it, and that's going to return the positions. And so here we get this much cleaner looking data set in comparison to this other one. So yes, at its core, a which function returns the positions which are true. But the practical reason we'd want to do this is that this then allows us to overcome issues like the presence of missing values in logic during an extraction. So that's kind of the power of which. That's how we'll frequently use it in data cleaning scenarios. Okay, next question is asking what will some of these return? These are fairly simple ones. We're just going to go through them fairly quickly. Here I have a integer vector. If I visualize that, it's just literally 1, 2, 3, 4, 5. I'm then comparing it to the number 2, and the equals stands for like, is it exactly? Excuse me. And so I have 1 compared to 2. Is it 2? No, it's not. False. Is 2, 2? Yes. True. Is 3, 2? Nope. 4, 2? Nope. 5, 2? No. Hopefully you're predicting that one correctly. This next one is the exact same question, except this time it's the opposite. So not equal to 2, and so we're going to end up getting the opposite logic. True, false, true, true, true. Next one, again, same concept. You're taking each of these values on the left, so you're comparing them to the value on the right. True, true, false, false, false. This time it was a less than symbol, and so we're testing, is 1 less than 3? True. Is 2 less than 3? True. Is 3 less than 3? False, and so forth. Now, I did find some students, I think were tripped up by this one, but maybe it's just the context of it being an exam question. That's kind of the thing, is that these are very simple concepts. This is just, do you know how to read these symbols? This is actually closer. This is kind of like the minimum difficulty you would see on the test. You're not going to see one at this level. This is too simple. This is more reasonable. In this case, though, I'm using some complicated numbers. I think it gets a little bit easier if I just give you some different numbers. So let's see. It needs to match up. So it needs to be 12 plus 5, so 17. Right? Is that 5 values long? 1, 2, 3, 4. No, it's 6. Math. Bear with me. I'm like into this an hour long. Okay, so here we'll just change those numbers. So it makes it a little bit easier for you to understand, and we're just going to be copying that downwards just to help you out in the future. When I do this, I now have a series of values on the left. I am then generating some logic here on the right. So that's just from the previous example. Just go look at that previous example, but that's resolving to true, true, false, false, false. That means we're going to be applying that logic to this object that was created on the left. And so we'll extract the true, the 12, the 13, and then not the 14, 15, or 16. Let's try that again. This time we're doing that same process, but we're going to flip the logic here. So the exclamation point stands for not. Literally not. So not 1 through 5 less than 3. And so that would be false, false, true, true, true. It's the opposite of the logic. We're going to apply that to this same data set. And so this time we'd be extracting that third, fourth, and fifth value, because that's third, fourth, and fifth values are true. Cool. In the original poll, I just said 1 through 5, but it doesn't matter what those values are. What matters is the values to the left are what's being extracted from. The values inside the square bracket don't matter. The logic that it's producing here is what matters. So I just wanted to make sure that was clear to you. That's why I changed the numbers, to make sure you were aware. Okay, next up, we got the following line of code return the following data. So we have this code right here. And the goal is rows of iris where the sepal length is equal to or less than the third smallest unique value in sepal length. Okay. Well, I've already calculated this for you a little bit. I found the unique values of sepal length, and the unique function does what it sounds like. It finds the unique values. I've then sorted it, which does what it sounds like. It sorts the data you provide it, which always sounds useful, but it only sorts exactly what you give it. So you can't use it for indirect sorting. It just sorts what you give it. But it does sort it here in order, and then I've extracted the first 3 values. So that's what localvals stands for, 4.3, and then the third smallest unique value would be either the third value, or I could calculate, say, the max of that. Okay, so then I say the rows of iris where the sepal length is equal to or less than that third value. So let's make that inequality of iris sepal length less than or equal to. All right, and it is the rows of iris is what I'm trying to extract. And so I could put all of that inside of a square bracket tool. I'm just adding some spacing there just to help you visualize what's happening. None of those spaces are necessary. So just to check all my work, I have the max value. Cool. I'm comparing it to a bunch of sepal links. That should generate some logic. Okay, that makes sense. And then I'm extracting the rows where that's true. Okay. And then if I go back to my poll activity, scroll down to that question, 9, 14, 39, 42, 43, 9, 14, 39, 42, 43. Did, good. I can then look across here. I can see that I did in fact use max, although I could have used the third position as well. That would have been perfectly fine. The min, certainly I would throw those out immediately because those would have been 4.3, and that's not what was limiting this. I also say less than or equal to. And so like less than or equal to the min would require that those all be 4.3 since that was the minimum value within this data set. So it's got to be the max. We can eliminate all of those choices. Okay, then looking between these, I can see that this top group has $ sepal length. This second group has just iris. Well, it's clearly the whole of iris that's been extracted, so I can eliminate all of these three. Finally, the difference between this group of three is that this one has a comma here, this one has a comma here, and this one doesn't have a comma at all. And so between those, this is the one that's using the logic in the row section of the extraction tool. And so this would be the right choice. And the process of like, without sitting there and getting to play with R, that's the process of how I would go about figuring that out. I showed you how I wrote it, but how I'd expect you on the test is, well, look at your choices. I'm giving you the different options based on probably the 1 to 2. Here I'm looking at 3 because I try to write the test questions slightly less than these poll questions. Well, other direction. I write the poll questions slightly harder than the test questions. But that's the logic I'd want you to go through because that's you're demonstrating your understanding of how this code works. Here that I'm extracting a data frame, well, I need to be extracting multiple columns of the whole data frame, not just from this extracted vector. It's like you do need to understand it in order to be able to make these choices. And again, you often have a lot of answer choices, so you have to be able to narrow it down by applying your previous experience to this code and some strategy. So this is your chance to practice. I hope that helped. Let me know if you didn't. That's a really good example. Okay, which of the descriptors describe the data returned by the following code? Here I'm doing some call names of iris. That gives me this information right here, which we're probably familiar with, but I'd always include this type of information on the exam just to make sure you did remember. Then I say sepal.length, spelled correctly, capitalization intact, so that should be returning true. Sepal.width, again, spelled correctly, capitalization intact, that should be returning true at some point. And made up column, well, that's done. It's made up. So it's not going to be in there. Then call names of iris. Well, that's going to be these values. And then percent and percent takes each value on the left and analyzes it compared to the right side. And so it's going to return true or false for each value on the left. That means it's going to be true for that first position of call names. It's going to be true for sepal width. It's going to be false for petal length because that's not in this vector. And it's going to be false for petal width because that's also not in this vector. And it's going to be false for species because it's not in this vector. So it is going to be all the values in column 1, all the values in column 2, and not 3 or 4 or 5. It's not all the values in a row because we've omitted 3 of the columns. So I wouldn't choose any of those all rows. There is no column of missing values because we were testing each of these columns in iris. It wasn't the other direction. Anybody who chose that one, they were kind of thinking of it backwards. So the extraction, so what goes used here, will be true, true, false, 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 which is appropriate for extracting from iris. So no missing data needed. That's a data frame class object. Lovely. Given the following object, which of the following would extract rows that have numvec values between, but not equal to, 10 and 20? So that means they need to be greater than 10 and at the same time less than 20. And so if we look through our choices, here is one that is greater than 10, and here is one that is less than 20. Here's one that's greater than 10, and here's one that's less than 20. So it's definitely between these two choices. And so the question comes down to, should we use the or the and? Well, I want it to be both at the same time. And so greater than 10 and less than 20 simultaneously is going to give us the values that are between, but not equal to 10 through 20. Let's talk about this other one in a minute. Next time, it says, how would I extract rows from numvec with values not between or equal to 10 and 20 as a data frame? So here we have less than 10. That's part of what we want. Here's greater than 20. That's part of what we want. And it's joined by an or. And then we have here less than 10 and greater than 20. But this time it's joined by an and. So please find a number that is simultaneously less than 10 and at the same time greater than 20. And you can take as long as you need to. There is no such number. I hope you realize that. There's no number less than 10 and at the same time greater than 20. Doesn't make sense, right? How could it be both? It can't. This, in fact, returns nothing because there is no number simultaneously with those properties. But there's plenty of numbers that, well, there's infinite. There's infinite numbers that are either less than 10 or greater than 20. So there's infinite minus, I guess, 11. So 10 through 20 inclusive. Infinity minus 11 is how many values that is. Cool. Next up, we have ends up selecting all rows as a data frame. Well, that's going to be this one because it's simultaneously greater than 10 or less than 20, which is every single number. Every number is either greater than 10 or less than 20. In several of them, so 9, are both at the same time, but 11, 12, 13, 14, 15, 16, 17, 18, 19, 9 are simultaneously greater than or less than. And then the kind of the last combination is this right here, which would be less than 10 and greater than 20, which is where you get nothing because there's no such number that is both of those attributes. Okay, and that's the end. I got to go figure out how to edit these multiple videos together, or I'm just going to upload them separately. But I hope that helps. Let me just make sure there wasn't anything else. Nope, that was it. All right, thank you. Bye.